name is Jenny Midwinter, and my talk tonight is going to be about a CNN-based autopilot for a wheelchair. So this is part of an autonomous wheelchair project that we're working on at a small company in Ottawa. So this part of the talk just focuses on the proof of concept that I built last year. So first of all, how many people know what a CNN is? Most of you do, some of you didn't. So basically CNN stands for convolutional neural network, and it's just a type of specialized deep learning or multi-layer neural network that's become very popular in recent years and is very good at doing predictions from image data. So my story starts with my brother. This is Stuart Midwinter. He's my brother. He is a C4, C5 quadriplegic from breaking his neck in 2011 in a paragliding accident. So for those who don't know what a C4, C5 quadriplegic is, that means he's paralyzed from the chest down. He cannot use his hands, and he has limited arm movement. So back in 2016, we were having a conversation, and Stuart was telling me about how difficult it was for him to get out in his environment. He really liked to go on the pathways and the bike paths near his home, but he found that he was tiring easily. So the way he explained it to me was he would have to engage his joystick with his hand like that, and he said that it was equivalent to doing a plank exercise because it's a very small muscle in here that he was using to control his wheelchair. So I was thinking about it, and I thought, hey, maybe we could make an autonomous wheelchair that would allow him to navigate through these pathways and come to a nice stop at the sidewalk, and I'll give him user control, and then he would cross the street on his own and then continue on the pathway on the other side of the street. So about that same time, I was taking a renewed interest in machine learning, and so I thought about CNNs, and I was very interested in CNNs on how they were able to do predictions based on images. I also was looking at the cognitive and neurological challenges for some other people in wheelchairs. So these would be people who are suffering from a neurological condition like ALS or some other degenerative disease like Parkinson's, where they would really like to be in a wheelchair, but they can't actually control it. It's actually really hard to drive a wheelchair. I don't know if anyone here has ever tried it, but it's hard, even for an able-bodied person. So I started researching to see what was done in academia and places like that, and I found actually there was quite a few places where people were working on this. One place was here in Montreal, actually at McGill University, under Professor Joël Pinault. There was a group there, and I visited them in 2016 several times in their labs and looked at what they were doing. And what I saw was that they had wheelchairs. They had a lot of very expensive sensors on these wheelchairs, and there wasn't much room for an individual. So I thought about what I wanted to do, and I set these goals for myself. First of all, I did want to provide this sort of lane assist to autonomously follow a pathway or a sidewalk or a hallway. I wanted it to be low cost, and most importantly, I wanted it to be able to be retrofit to a user's existing chair, so they wouldn't have to switch their chair. They just keep their chair, and this equipment would be very easy to add onto it. I also wanted to open source the software so it would be available free of charge. Some other applications that I also looked at for autonomous movement of the wheelchair were two things called Follow Me and Accompany Me. So Follow Me would be an example of that would be where you have someone who's maybe in rehab and learning to walk again, and they can walk for short distance of time, but they tire easy. So in that case, the wheelchair would follow along behind them, and it would be there when they tired so that they could use it. The Accompany Me idea came from my father. He was suffering from ALS and at that same time, and he would like to go out for walks, but he had to use a manual chair, and I would push him from behind. And I found that really unsatisfying to be behind my dad. I'd much rather prefer to accompany me beside him. So that idea there is to have the wheelchair automatically follow someone, just like two people walk together side by side when they're talking. There's another application as well, automated docking for battery recharging. It's really difficult for people to plug in their wheelchairs to get recharged, so I've been looking at that, but I won't talk about that too much in the talk this evening. So very early on, I decided I would make some I guess I made some early decisions. First of all, I wanted to build a proof of concept because I really didn't know anything about this area, and I thought I'll just try and build something and see what I learned from that. So some of these early technical decisions that I made, or straw man decision, is first of all, use a CNN. I wanted to do that to predict the steering angle, and I wanted to do that from one forward-facing camera. And this is inspired by a paper published in 2016 called End-to-End Learning for Self-Driving Cars. So at the end, you can see my references if you're interested in those papers. But I actually did take that paper and I implemented that algorithm, trained it to drive a car inside a simulator. And that was around 2017. So I wanted to use that one. The second thing I decided to do was to use this 8-fold smart chair. So this is a company, a small company in Ottawa that I'm collaborating with, and they provided a way of being able to interact with the wheelchair programmatically to be able to give it commands to move. So that's a great starting point. I also wanted to use ROS. I don't know how many people here know ROS. Ever heard of it? Robotic Operating System. It runs on top of Linux. It's basically a real-time processing environment to support this type of work. Finally, one of the things I did as I was building this proof of concept is I made another shortcut decision. So in 2018, a group from the University of Zurich published a very interesting paper called Learning to Fly by Driving. So they had taken they had developed an autonomous drone that could fly at about this level. And they had trained it to fly on a car driving data set, actually the Udacity open data set. And I thought that was interesting because that was one of the data sets that I was using and wanted to use. So, and the second thing they did is they had a manually annotated data set to detect collisions. So with those two things, I thought very quickly I could plug that in and just get a baseline and start. And then later on, once I learned more, I would know about the type of data that I wanted to collect and train on. So here's what I finally built. This is the proof of concept autopilot for an autonomous wheelchair. So at the first part here we have a, let me just see here, yes. Okay, here we have the forward-facing camera here that it takes the image, and then that goes in, does some image pre-processing, and that goes into a CNN, a trained CNN, that then produces two things, a steering angle and a probability of collision. Those two things I combined to create a joystick equivalent command. So now we're just going to take a look at a demo of this. So I haven't given it any directions or navigation here. I've just said please go, and obviously don't run into anything. So here it is driving by itself. This is the a beta version of it, but there's a camera at the top here. It's a bit hard to see at the top of the wheelchair, a single forward-facing camera, and it's grabbing the images, and the image is then being sent to a laptop computer that I have nearby that's running, and that CNN that I told you about. It's producing the probability of collision and the steering angle, and it's making decisions. I turn that and I send the command back to the wheelchair. So here it is. This is, as I said, trained on car driving data. So you see here it coming up, and it's actually stopping quite well, slowing down as it gets to that wall and it comes to a complete stop. Okay, so how did I do this? So I started off with, I mentioned, this 8-fold smart chair. So what they had developed is a product that they do sell for people who need it, is a way to control your wheelchair from a remote control method. It's basically you have an app, and on your phone app you have a virtual joystick, and then you can move the wheelchair based on where the finger is on the screen of the phone. So this signal then is sent over low energy Bluetooth to a custom Arduino board that's on the back of the chair. So how many people know what an Arduino board is? A few people. It's basically a really small, inexpensive computer. And then that Arduino board then generates the proper electrical voltage levels to drive the wheelchair to send the signals to the wheelchair motor control. So this is what it looks like on the back of the chair. There's this is the custom Arduino board that's back there, and it's open. I have the lid off it so you can see what it is. Basically, it looks like a small red brick, and it's powered from the wheelchair battery down here. So this is a close-up view of what it looks like here. The Arduino board is actually underneath, but this is just all the extra circuitry that's needed there in order to generate the right voltage levels. Okay, so what I did then is I replaced that app with a laptop and running a CNN. This was the alpha version of the product that I created. So it took the USB webcam, connected that and the Arduino board directly to my laptop, and then I ran the CNN in there, and that's basically the images came from the webcam to the laptop. So basically that just replaced the virtual joystick. So here is just, I won't go through this chart, it's very busy, but basically this is the software that was developed in order to do this. So on the left-hand side, over here, right-hand side, or left-hand side, here is where the CNN is running in this module here called Perception. So the purple bubbles are the software that was developed, and the sort of light purple ones are software that I used that I modified for the purposes of the wheelchair. So my AI stack that I used in this particular case was I always had Keras. I don't know if people know Keras. It's a way to define a model running on top of TensorFlow as the back end, and that was running on top of CUDA to allow the parallel processing to take place. So I had this running on a number of different platforms. Some of the times it's on a GPU, sometimes it's on a CPU. A lot of the extra code that I added here was to allow me to make sure that things were working properly. So I spent a lot of time developing code to understand why the CNN was making the decisions it was making. So it would let me know in real time why it was deciding to do, and I also would record it along with the images so I could go back later and see what was going on. Okay. So what are the results of this proof of concept? So basically what I could see happening is that basically the self-driving operation was tested in a variety of environments and pathways, indoors and outdoors, sidewalks, roads, hallways, and it would drive on its own for short periods of time, and it was usually stopping on its own well before running into anything, except I had a problem with low-lying objects like a curb. I think it's proven to be viable as a platform, but of course lots more work was going to be needed to make it better. It really helped me to identify all the next steps and the focus. So I think what I could see was that I think the CNN really is a viable solution to develop a wheelchair autopilot. So what else did I learn from this proof of concept? I learned a lot of stuff about the wheelchair and that area. I learned that the wheelchair actually drives more like a tank than a car, and that obviously I need better data to train in order to get the improvements. I kind of knew that ahead of time, but I just wanted to make sure that conceptually this thing would work before I spent a lot of time developing and getting data. So I'm in the process now of getting a lot more very specific data specific for wheelchairs, and I've had to create a data collection box for that as well. I also, as I said, the collision detection and stopping worked well, but it missed low-level objects like curbs. And finally, I spent a lot of time around image pre-processing, locating the height and location and the type of camera. The angle that the camera is at also made a big difference. So a lot more experimentation is required in this area to get a good product. Some other observations in learning, so if anyone else has worked in the area of machine learning and doing this type of work, is that it sounds really cool what you're doing, but the reality is that it's a lot of time spent doing really unglamorous things like installing software, resolving intercompatibility issue, getting bugs in open source code, and working with these data sets, getting them installed, working with them, and reproducing things that you've seen in papers, setting up the development environment. All this takes an awful lot of time. In fact, most of my time was spent in that area. I also spent a great deal of time instrumenting the software and the hardware as well to test and debug and to make sure that the wheelchair was actually doing the correct behavior. So, in conclusion, I think this type of technology, I think it's going to be really helpful to people. It's going to allow those with neurological deficiencies to be able to accompany able-bodied companions. I think it's going to allow those with more severe mobility impairments, more freedom and independence to get out into their environment. I also think that the autonomous driving techniques can be adapted for use in these less structured areas. Like cars usually drive on roads, which is very structured, which makes it easier. But I think we can adapt those things to work on sidewalks and pathways and hallways and shopping centers. I also think that the machine learning algorithms that are being developed in academia now, like from some of these papers, can be taken in a low-cost way and applied using standard R&D practices. That's almost the end of my talk. This is the team. We can introduce them later. And finally, this is, we learned from our errors. I thought this was a fun one here. I'll just end in this one. One last video where things didn't work out. I think it's pretty funny. You can't hear me saying, but I'm saying test number 1. So run it again. Test number 1, and this pedestrian's coming down the road here and completely blew it for me. So it was going nicely, and now, and you can see that. If you can see, I have my computer inside a box. It's really hard to work on this stuff out in the environment, and it's jiggling around, and you can't see anything. So anyway, that gives you just a flavor of it's really quite difficult to get all these things. So that's it. I've used up all my time, so I'll take questions afterwards if you want to ask me. I'll be here.
Thanks so much.